Okay, our next speaker is a paleoanthropologist. He's a professor in integrative biology at UC Berkeley and a member of the National Academy of Sciences. Our worldview of human evolution has changed dramatically during the last 30 years, and Tim has been at the center of much of it. He's excavated, described, and analyzed some of the most important fossils during this time period, including the Laetoli footprints and Lucy. Most recently, his work was featured in a special issue of Science describing Ardipithecus ramidus, a 4.4 million year fossil, which is at the dawn of humanity. So, without further ado, here is Tim White speaking on Light Will Be Thrown on the Origin of Man and His History.
Thank you very much. I'm an experimental biologist, but I have to qualify that. I work on mostly dead and mostly rare organisms, and I work on the results of a very large and complicated experiment that can't be repeated. Try that. I was basically saying that I'm an experimental biologist, but I have to qualify it because I work mostly on dead and rare organisms and mostly on an experiment that was very large and complex but can't be repeated. So it may be better to think of me as a forensics person, a crime scene investigator, which, as we go on with the loss of biodiversity, seems to be more and more appropriate, actually. But today, because of the topic of the conference, I want to talk about hominid paleobiology. How has Darwin done in the retrospective of 150 years? We start in 1859. And Darwin didn't say very much. In fact, you've already read everything he said about that clade, this little one up at the top. It didn't take him too long before he turned his detailed attention to this target organism and tried to explain how it happened in the 1871 book. Darwin knew quite a bit about the living great apes. And indeed, in 1871, he famously said it is somewhat more probable that our early progenitors lived in Africa than elsewhere. But often the next part of that phrase gets taken away. He says it is useless to speculate on this subject, and then specifically goes on to lament the lack of a fossil record for these forms. So when faced with a choice, the cartoonists of the day split between characterizing an ancestor like a chimp versus an ancestor like a gorilla. Of course, here the parody from those cartoonists is in showing how ridiculous it is to think that we evolved from anything like an ape. Darwin himself is tough to track down. Many of the icons surrounding Darwin are chimpanzee-based. But when you go to his one phylogeny, this one never published, this 3 years before the 1871 book, you can see here that he has humans on the left, and he's not advocating the closer relationship with the African apes. You can also see that he's crossing things out. If you go and look here, where he has the gibbon, the orangutan, and he puts gorillas and chimps on a single lineage, and then humans over here. And he has some ambiguity here. It's man, and then homo, and then man again. You can see Darwin is hedging his bets, as it were. But in 1871, he's very clear on this point. We are not concerned here with hopes or fears, only with the truth as far as our reason allows us to discover it. I have given the evidence to the best of my ability. And the evidence for human evolution, specifically from a fossil record, was extremely poor in Darwin's day. And it led directly to a myth, and if I do nothing else today than debunk the following statement, it'll be declared a success from my point of view. Steve Gould, in his final statement on the subject, said no true consensus exists in this most contentious of all scientific professions. He doesn't say how he quantified this as being the most contentious of all scientific professions, and I'm not going to debate that. A field that features more minds at work than bones to study. Not true. Darwin was very clear on the fact that we had no human fossil record, or virtually none. Nor should it be forgotten that those regions which are the most likely, and here he predicted Africa, to afford the remains connecting man with some extinct ape-like creature, he doesn't really specify which one, have not as yet been searched by geologists. Now I'm going to have a series of questions through this talk that Darwin might have asked had he been alive today. And Peter, I'm going to ask you to give me the sort of the phrasing after the talk. I've done it in American English, but I'd love to have the Victorian English version of these questions for the. But Darwin might ask in 2009, have such remains now been found? And if so, where might we go to see them? And if I were to be able to take Darwin to see a place where such evidence has been found, it would be easiest for me to take him to where I work. I could put his name on the permit. The Ethiopian government issues us each year. We would go to Addis Ababa, and then we would travel to a place called the Middle Awash. It's a region in Ethiopia where we've been conducting scientific research since 1981. We have a lot of specialists on the project, spanning a lot of different scientific disciplines. We have many people from many countries on this project. It's large and international. We've recovered about 19,000 cataloged vertebrate fossils, including 290 hominids. I told you I work on rare organisms. That's a good indication of this. And we've shared our data via publication with a lot of printed pages that I'll try to summarize here today. I have a much more interesting way to off Darwin than just drowning him. Let's imagine that the Beagle turned north and tried to take a shortcut through the Gulf of Aden up through the Red Sea, where Darwin would have to do a short traverse to get to the Med and get home. But on the way, of course, you couldn't have stopped Darwin from wanting to stop the Beagle and go on one of his walking journeys. And if he had tried to do that in the Afar, it would have been a much more effective way to take Darwin out of the picture. Not only because, well, piracy, there's a lot of piracy here, probably more piracy here today than there was then. But if Darwin had tried to walk into this area, across this desert, up against that escarpment, which is the Ethiopian escarpment, he would have crossed through the study area that we work in. It is called the Middle Awash. It's in the Afar Triangle. It's where the continental East African Valley comes up and intersects this flooded rift valley, the Red Sea, and that flooded rift valley, the Gulf of Aden. Darwin might have asked, why are you taking me here? Why this place of all places? And the answer is, in a word, tectonics. Because the tectonics that have created those rifts create that depression, and that depression has been the recipient of sediments washing from the Ethiopian highlands for millions of years and accumulating in the lakes and rivers on the floor of that depression. That rifting has also weakened the Earth's crust so that magma can escape. It escapes in the form of fantastic volcanics. Here we have this continuing even today. 2 years ago during the field season, volcanic eruption, November 2008. It's not a cloud, it's an ash cloud, a vast mass of volcanic glass rising up that then drops and mantles the landscape. And this has happened for millions of years. So if we think about Lyell and go back to those days, 1863, no subject has lately excited more curiosity and general interest among geologists and the public than the question of the antiquity of the human race. And it is through these conditions that we can estimate with a great deal of accuracy the antiquity of the things that we find, because we find them interbedded in these volcanic layers. Now, let's start with Darwin and what he had in the way of a fossil record. It must be admitted, some skulls of very high antiquity, such as the famous one from Neanderthal, are well developed and capacious. It must be admitted. Well, what he's admitting is he doesn't have anything older or more primitive. Well, he's got Neanderthals, and he might ask today, have you found any? And we would have to answer him, not here. Not in this place. But we have found some things. We have found here, at around 80,000 years ago, a place called Duma, sediments were being laid down on the top of approximately a kilometer of total sedimentary thickness, right here. And in the upper horizons, at around 80,000, you have anatomically modern people, and you have their stone implements. This one, a Middle Stone Age point made on obsidian, here at the top. And we're going to step our way down through this kilometer of rock very, very quickly. We step down to 100,000 years ago. You see the badlands eroded. These are ancient sediments eroding on the floor of the Afar. And when they erode, things like this mongoose skull and this monkey skeleton erode out from the sediment, along with these stone tools. These are at the 100,000 year mark. This is Gedewalde Gabriel, a project geologist who found a skeleton of a hominid, anatomically modern human, a very large individual, very fragmentary. Dr. Berhane Asfaw, my colleague in Addis Ababa, is piecing the cranium together as we speak. So that's from fairly far up on the top of the sequence. Let's think about this geographically. We'll zoom into the Afar. We start to see all of these dots. These are our paleontological localities. They're scattered around these geological outcrops. We close in and we see here a village that the local people live in. It's called Herto Village. And at Herto Village, we see nearby these dots. Each one of them is a vertebrate fossil. And we zoom into the ground. We can see one of these vertebrate fossils. That's a hippopotamus cranium eroding from a sand that we have radiometrically dated by capping and underlying layers to 155 to 160,000 years ago. We extract the hippopotamus, put it back together again, find things like archaeological evidence of butchery of this hippopotamus. We find tools like this, and we find hominid remains like this. This is how they come out of the ground. They usually come out of the ground like that and not like that, but we can put them back together again. Dr. Asfaw put that back together again. This is the skull of a child, about an 8-year-old, and this is the skull of a large adult male. And this is one of the earliest anatomically modern people in Africa. It's not quite modern. It's got some primitive characteristics to it, large superorbitals and a rather robust occipital. Darwin might ask, after looking at that and realizing it's not a Neanderthal, Darwin might say, well, what about those Neanderthals? From where did they come and where did they go? When I started off as a graduate student, arguably Steve Gould was right about the fossil record. This was a European form, about 500,000 years old. It's called the Mauer mandible, found in 1908. Endless discussions and dissertations about what this jaw meant. Now you could take that specimen and just toss it. It really doesn't matter anymore because of these discoveries in northern Spain, made by my colleague Juan Luis Arzuaga. He has found literally thousands of pieces, virtually every part of the body, from men, women, and children, in a single cave depository. This is effectively a population of early hominids that are early Neanderthals. Here is one of the crania that came out of that, just to represent what's going on in Europe at around 500,000 years ago. We can track these Neanderthals through time now. We have many of them. The earliest people appear at 160,000 years ago in Eastern Africa, and the last Neanderthals go extinct long after that at around 30,000 years ago. Fortunately, some of the cave conditions with these Neanderthals are cold enough so that DNA has been preserved. It's been extracted, both mitochondrial and nuclear. And Svante Pääbo has been doing this very exciting work that tells us a lot about Neanderthals and where they came from and where they didn't go. Now, when we go back to those Victorian scholars and look at them looking at their predecessors, the people like the French archaeologists who saw things like hand axes and wondered where they came from, we might expect Darwin to ask, who were the makers of these hand axes? We find them in layers earlier than the Neanderthals. Who might have made something like that? And let's go back to the study area. Here at 500,000 years ago, here, there, the window on our time scale, is a cranium from a place called Bodo. Now, anthropologists have a lot of trouble with this because they have a hard time labeling it. Some of them call it archaic Homo sapiens. Some of them call it advanced Homo erectus. Others call it Homo rhodesiensis. It's all the same skull, just different labels. It's a fantastic intermediate, one that you should often use when a creationist claims there's no hominid intermediate in the fossil record. It's intermediate temporally and morphologically, and indeed appears to be the hand axe maker. Darwin might say, wow, that's all from a single valley in Ethiopia? We can find earlier versions of those hand axes here at 1 million years ago in association with this fossilized cranium found in situ, now being extracted. This is Henry Gilbert, the guy who found it. And this is a micro CT scan showing you what the anatomy of this creature was like, at least without the face. One of those things where we found it, the face was down on the ground. We took the whole jacket out, took it back to the lab. A couple of years later, you find out there's no face. A 1 million-year-old carnivore got there first. But beautiful cranium can be compared with other members of its apparent taxon all across the old world at 1 million years ago. Now, Darwin, I think, would not have been so surprised to see that evidence, to see that progression. After all, he predicted it. He just lamented the lack of its having been found. But Darwin, I think, would be very surprised. And he might ask, did I see Abyssinians working with the fossils? And the answer is yes. The paleoanthropological pipeline that's been so productive from Ethiopia is largely based on the work of Ethiopians. Ethiopians in the field, Ethiopians along every step from the initial discovery through the laboratory work, the photography, the measurement, the scientific publications, and authoring things like this 600-page monograph published earlier this year by Johannes Haile Selassie and Gide Gabriel on some of the earliest hominids to come out of this area. Now, Darwin might ask, well, where can I learn more? And he'd be familiar with the traditional resources like those monographs where he could turn and read about that Homo erectus cranium published the year before by Gilbert and Asfow. Or he could go to this website. And it'd take a long time to explain the internet to Darwin, but he'd catch on really fast. You can go and get a lot of information. The entire catalog of fauna associated with that is up online with photographs of every one of the fossils found in multiple views. And Darwin, after digesting all of that material, and it probably would take him about 10 years to digest it all, might say, well, what came before these? Or maybe he'd just jump to the chase and say, what came before these? And what came before these, at least in this local area, comes from 2.5 million years ago. These are, we might want to turn the lights down a little bit in here. Do I have a dimmer switch I can do that with? Oh, the guy in the back's freaking out, man. He's saying, don't touch the lights. All right, I got you. We won't touch the lights. This is the earliest hominid technology in the form of very primitive stone tools comes from these horizons in the Pliocene of the Afar. And it comes with a form of Australopithecus that's still, as of yet, it's very poorly known. We don't know much about this Australopithecus, although the genus Australopithecus we know quite a bit about. Remains of it began to be found in the 1920s, followed by materials in the 1940s, and it took a long time for people to be convinced that these were even cladistic hominids. LeGros-Clark, very important in establishing the hominid status of skeletons like this partial one from Sterkfontein. In the 1970s, in Ethiopia, a partial skeleton was found and subsequently dated to approximately 3.2 million years ago. And this, for a long time, was the earliest of the relatively complete hominid skeletons, and a great deal has been learned from this skeleton, and even more will be learned from it as we go on. But it's been hard to push that knowledge back beyond the 4 million year mark, and it's only happened in about 3 places now. A couple in Kenya, a couple in Ethiopia. This is Australopithecus. It's been given a new name, Anamensis. It's the earliest Australopithecus, and it's around 4.2 million years ago. All right. Lots of fossils, lots of dates, but I want to make a couple points about that. Let's go back just to show you that. Let's think about this jaw. Let's think about finding that jaw on the floor of the Afar Depression in Ethiopia. Where do we look? Well, we are guided by geology. The geology tells us that this is an Afar village out here in the distance. Just this side of the village, there is a little erosional patch of sediments between volcanic ashes again, And we go right there and we can see the jaw. The photographer's taking a photograph of the jaw. I know you can't see the jaw. You've got to go closer and look at the photograph. That's the jaw, the one you just saw. So how do we get the... come on, you're saying that's gravel. True, initially. You carry it out in sacks, you wet sieve it, you concentrate it, and then you pick the concentrate. While you're picking the concentrate, you run into things like the teeth of mice, which are extremely valuable because they'll tell you something about the environment that this hominid was buried in. And those are the hominid pieces of gravel. And then you piece them back together again like that. Now, that's good news and bad news. It's a beautiful palette of an early Australopithecus, and there's more good news. You don't need a CT scanner. But it takes a long time to get it, put it back together again, interpret it. We published that in Nature at the 4.1 mark in 06. And various other publications. This kind of reviews what we've looked at. We've seen an archaeological record stepping down. We've seen a hominid record stepping down. A lot of fauna, but I'm going to draw your attention to this one right here. This is really the bulge in the snake. As you can see from the number of identified specimens, 6,400, hominid specimens, 114, published initially in 94 and then earlier this year. We're going to focus in on that, but before I do, I want to give thanks to the large team of individuals who participated in this work. I have 47 authors from 10 different countries, with special acknowledgments to Desmond Clark, who started this project. He was an archaeologist at Berkeley, and Maurice Taïeb, the French geologist who first explored this region, and it, even today, is quite a hostile and dangerous region. So here it is, the study area. We see we've just reviewed these dots. We have archaeology about halfway down the succession. We have hominids in many horizons up and down. We're going to focus in here. Spatially, we're going to focus on this big bulk of data that sit right in what we call the Central Awash Complex. The Central Awash Complex is visible from that earlier site that we were on where we found the broken maxilla. We look out over the complex, and everything's out there is fairly flat. You're effectively on the off-our floor, but fortunately the tectonics have popped up some of these ancient sediments, the 4.4. Actually, they popped up even earlier sediments. If you go right over under these mesa tops, those mesa tops are a basalt flow that's dated to 5.2. And under that, we have lots of fossils, but no hominids whatsoever. It appears to be the wrong environment for hominids this early in time. So in order to get a perspective on where we have found the Ardipithecus materials, we have to go up in the light aircraft with a camera, and we're going to look down sort of in that direction into a drainage. We look off in the distance, we see the Awash River running up toward the Lucy site. This is Aramis, that's where the name comes from, this little catchment. And we started to find hominids there at Aramis VP1 back in 1992. We found some more in 1993. We named a new taxon. We found other localities, spotting all over the place. And we're going to look at that one by, again, going up in the air, but this time on a helicopter. And we're going to look right down on the ground. And that's what it looks like. This is the field team, and this is how we collected those deposits. Not 1 year, not 2 years, but multiple seasons in a row, people shoulder to shoulder, crawling across the desert and picking up every single item. Now, you can't usually do that at these early hominid sites. You can do it in this case because you have very tight chronological control. The beauty of those volcanic eruptions. This is a basaltic ash that mantled the landscape. It's been dated to 4.4 million years ago. They're crawling across fluviatile sediments. Another 2 meters down, you get another volcanic ash, but with an identical date, 4.4 million. So we have a temporally controlled sandwich, and we have it exposed across about 9 kilometers of landscape. So we can collect everything that's been preserved from that horizon, and that's indeed what we've done in operations like this. We're back down on the ground again. What would you see if you were joining that crawling line? You would be picking up things like this. You easily see that's a fossilized millipede. They're gastropods. Land snails are very valuable for ecological purposes. Fossil wood, fossil seeds. Here is a dung beetle ball that was embedded there 4.4 million years ago. So quite a complete set of remains, but you also find things like this. These are the finger bones of mice and rats and bats and shrews There are amphibians in there. It is the entire small mammal fauna, and very occasionally you'll find one of these very rare primates, and this is the large toe, we'll come back to that in just a minute, of a hominid that we excavated from this horizon. So before we get to the hominid itself, we want to talk about the ecological context that we've been able to put together with these data. This is a number of identified specimens, again, about 2,000. Most of them are spiral horned antelope and monkeys. Hominids, all of the other bovids are right here, which is very unusual for a hominid site. Suids, carnivores, horses, hippos, aardvarks, giraffes, proboscideans, and then you've got some miscellaneous ones there. These are just the large mammals. We looked at the mesoware, we looked at the enamel microware, and we went to, thank you, we went to the enamel isotopics to look for the placement of the hominid remains attributed to Ardipithecus, shown here by the yellow, and they cluster with the C3-based browsers as opposed to the C4-based grazers. All of these taxa are actually quite rare at the site. Those monkeys that you saw and the kudus that you saw, they're the abundant fauna, and that's an indicator that we're in a very, very closed habitat, to make a long story short. Now, the excavation itself, the hominid skeleton, the most complete one, was found in a very tight spatial and stratigraphic arrangement. Nothing was articulated. The bones were fragmented before burial. The fragments continued to get smaller during burial because of the expansion and contractions of the clays that they were embedded in. So it would take 2 or 3 hours to expose a metacarpal like that. All of these came out of the ground in plaster jackets and were transported back to the laboratory that we built in Addis Ababa, where they have remained ever since, except for one short trip to Japan. This is, just for reference, this is the left hip bone of that skeleton. And you see the top of the hip joint, the bottom of the hip joint, there's a big crack through there. There is a bump called the anterior inferior iliac spine that's quite important. We clean that up by softening the matrix, which we had to harden in the field to extract it, and taking it off a millimeter at a time with acetone under a binocular microscope across every single one of those bones. And it cleans up pretty well, actually. There's intact bone from that anterior inferior spine all the way back to the sciatic notch with very little displacement, very little intervening matrix. It's a very broad bone in that sense, but before we go to that, let's talk for a moment about the cranium. This is Gansuo, my colleague in Tokyo, who took all of these pieces of the cranium, and here we're looking at a CT scan, his micro CT that sliced right through that squashed cranium. You see the side of the head, top of the vault has been crushed in, you see the cracks in the matrix. He was able to use that to do the mirror imaging and the piece separation to put the cranium back together again. We got all the isolated teeth as well, upper and lower jaw, and we can start to ask questions about the biology of this creature. We look to the brain. It is very, very small compared to later Australopithecus or living chimpanzees. In fact, it's right down there in the female chimpanzee range. The incisors are very, very small relative to chimpanzees. The molars and premolars, large relative to chimpanzees, small relative to Australopithecus. The height of the canine tooth, this is male chimpanzee. This is Ramidus, the one we just found, and there are males and females of that. So quite an interesting organism, something that is not specifically chimpanzee-like. It lacks the extreme facial prognathism of the chimp. It lacks this big groove above the orbits that the chimpanzee has. It has a very short cranial base that it shares with all later hominids. Fascinating creature. This is just a video to focus in on that canine tooth. This is a male chimpanzee canine, and this is a male Ardipithecus canine. We can say male because we have a large enough sample of different individuals. And the key things that I wanted to point out here are not just size. Size is easy. Look at the shape. It's V-shaped, saber-shaped, and more importantly, morphologically, it's a functionally honing tooth. These great apes sharpen the back of their canine teeth. This is a diamond-shaped tooth, very much shorter crown, and no honing has been found on any of the canines of this taxon. Let's think about the foot for a minute, because we have a foot associated with that biology. We're looking in here at the large toe, and we're going to swing around and look at this bone, which is the medial cuneiform. Think of this as your left big toe, and this is the joint that the base of that big toe articulates with. See how round it is? What that would mean is if this were your foot, and that's your left big toe, you could abduct it. It is a divergent hallux. It's the first time we've ever seen anything like that in a creature like this. So that's interesting, because all other primates, no matter how far back you go on the clade, share with Ardipithecus ramidus this grasping ability in the large toe. Thanks. Fascinating things about the hand. It turns out that there are no traits specific to knuckle walking seen in any of the wrist or hand bones. The pelvis that's pulled out has that great breadth I referred to before. Here it's compared with a human, the Lucy specimen, and with a chimpanzee. It has the beginning of a sciatic notch, no notch in the chimp. It's quite different. We think these are derived characters, but also has primitive characters in the ischium that indicate to us a facultative bipedality. In the foot, fascinating because we can see this grasping ability shared with the chimpanzee, not with the human, and yet, comparatively speaking, we can also see the chimpanzee has greatly derived its foot for grasping. So I want to just stop this organism. I know a lot of you are molecular genomics folks, and you think about chimpanzees as model organisms, and you think of them perhaps as common ancestors because there hasn't been anything else. So right now, I want you to think about this creature here and think about the thumb, how small it looks. It looks small because the metacarpals are so long. If we assume that long metacarpals are the primitive condition, we would be almost certainly incorrect. We've learned that from the fossil record. So this has fascinating implications for the genetic work that Greg mentioned yesterday. The foot has evolved dramatically in humans at the same time that the hands have evolved dramatically in the chimpanzee. So when we go back to those cartoonists of Victorian times asking the question, am I a man and a brother? Well, cladistically, neither one, we would say to this gorilla, and we would simply answer with the word sister. Now, Darwin would ask, what about my theory of how we evolved our bipedality brains, canines, and tool use all at once? Well, now we have evidence that we can look at that gives us some pretty good biology. It's not just this skeleton. It is a minimum of 36 other hominids, 110 cataloged hominid specimens, a context including a lot of data. And the picture that emerges is one of a partially arboreal, facultative biped with a feminized canine living in a woodland, eating an omnivorous diet. So, not a chimpanzee. And since I'm being hastened off the stage here, I think I'll just end it there. I was going to say a few things about the rest of hominid phylogeny and so forth and so on, but I think this is a good spot to leave it.